Chem 101 students, let's go ahead and do another one today. How about let's talk about the number of electrons in Lewis dot structures of ions, right? So remember, in Lewis dot structures, you only represent the valence electrons, meaning the electrons that are in the outermost shell in the highest energy level. So this one is taken directly from your homework. It is from Chapter 4, homework number 32. And it's a bunch of true-false questions. But the first one, it says, in magnesium oxide, O2 minus has 8 electrons, right? So I'm not a super big fan about how it's worded, but let's consult the periodic table. So O2 minus. So if we are O, we're right here. Now, if you are 2 minus, that means that you did what? You gained 2 electrons or you lost 2 electrons. Means that you gained 2 electrons. So you're 1, 2. So O2 minus would look just like neon as far as electrons go. This one is called isoelectronic. So oxygen would in fact have an octet. Oxygen would in fact have 8 electrons around it. It started off with 6 because we're in the column 6A, and it would go 6, 7, 8. So that one would be true. Now, magnesium 2 plus always has 1 electron around it. So magnesium 2 plus. Let's look at magnesium. We're right here, right? We have 3s2 because we're in the 3rd energy level in the s orbital, 3s2. And it says magnesium 2 plus. What would happen with magnesium 2 plus? We would lose 2 electrons. So we'd go from here, we go 1, 2. We would be isoelectronic with neon. So we would lose 2 electrons. So how many electrons would be around it? It would not be 1 electron, right? That would be magnesium plus 1, which really is not an ion that exists. So it would be magnesium, that would be isoelectronic with Ne. So it would actually have, essentially, we'll get into that, but the answer is no. This is false, right? This is where the wording gets you here, and I would not do this on an exam, but it says that in sodium chloride, Na plus has no electrons around it. So Na plus, right, so if we know that Na, sodium looks like this, and chlorine looks like this, right? So what happens is sodium 100% of the time gives its electron over to Cl, 100% of the time. And then you end up looking like Na plus and Cl with a perfect octet, right? Minus. So it's 100% of an exchange. This is a full positive charge. This is a full negative charge. So what it's saying is it has no electrons around it. Is this ever true? Right? No. The only thing that would ever have no electrons around it would be an H plus ion. So this is very silly the way they write it, in my opinion. But since it gave up its electron, let's look at what it's isoelectronic to. You're Na and you lost an electron, so you're going to go back a space. You're now isoelectronic with Ne. So technically Na plus has an octet, but it did lose its valence electron. So I'll just give the answer away here. The answer that it has here on the homework is true. The way that it is worded is very poorly, in my opinion. It's true. What I would reword this is say in sodium chloride Na plus has an octet, is what I would say. So ionic compounds with Cl minus, the chloride is isoelectronic with argon. So remember, isoelectronic means that it has the same electron configuration. Remember, 1s2, 2s2, 2p6, 3s2, right? It has the same electron configuration. So for Cl minus, if you're chlorine and you're Cl minus, that means you gained an electron. So you're going to go here. So you now have the electron configuration of argon. So the answer to that one would be true. So I hope that this helps. It looked like this one was a little confusing for some people, which is okay. That's what I'm here for.